Hello and welcome to today's daily Leetcode challenge. Today we'll be solving question 1887, reduction of operations to make an array elements equal. Okay, so let's go straight to the question. Given an integer array nums, let's see this integer array nums, your goal is to make all elements in nums equal. To complete one operation, follow these steps. So through n or some number of operations, we're going to attempt to make this input array equal, or have all the elements in the array equal. And these are the steps to reproduce one operation. Find the largest value nums. Let that index be I, 0 index, and its value be largest. Okay, so we assuming that the array is sorted, we find the largest value and have that be also equal to largest. Index sum n. Value be if there are multiple elements with the largest value, pick the smallest I. If there are multiple x's, we pick the smallest x. Right? If the value largest, if there are multiple elements with the larger value, pick the smallest I. Find the next largest value in nums, strictly smaller than largest. Let that value be next largest. So there is some x minus some number that is going to be next largest. Okay, next largest. And then we reduce nums I to next largest. So we reduce this largest value to whatever this was, x minus 1 or x minus whatever it is, x minus 2, 3, or whatever. So what is this one operation actually doing? Well, if we were to visualize it, and I liked visualizing these things because they make the problem more solvable. It kind of seems like, assuming that this is a sorted array, that once we start off with 1 point right here, we look at the next element, and then we see by how much we have to reduce this this next value. Now, the process of reducing it is just one operation. So once we reduce this, we move on to the next one and try to reduce this once again. I'm wrong, though. That's not the way to do this, because that would mean simply that we look at how many different values there are excluding the first one, and we just say that the result is n minus 1, n being the number of elements. Right? The result is n minus 1 if this is the right approach. So I'm doing something, I'm messing up, right? I'm messing up. I realize why I'm messing up, because I'm going from bottom to top, whereas here the process is actually saying go from top to bottom. So first look at this largest value, find its next largest value, subtract this number, reduce it to what the next largest is pointing to, and then go ahead and find the next largest value, which would now be this, reduce all of these, so far 4 operations, then find the next largest value, this one, reduce all of these, which would be plus 4 more operations, and then find the next largest, and then 1, 2, 3, 4, 5, 6, 7, plus 7. So the result here would be 4 plus 4 plus 4, 15. 15. Am I correct here? it seems like the process of reducing the array can't start from the initial value, because if we start with the first value, then we are easing the process of reducing the next values, because we can automatically reduce it to the smallest possible value. But the reduction here is gradual. We first reduce the largest value to what we think could be the next largest value, and so on until we get everything equaling 1 uniform array. So how would this work? Well, one approach is to mimic what I just did, which is to essentially have a start and a finish. And each time I encounter this fluctuation between what is here and what is here, each time I encounter that, to some result, I add the difference between the start and the end. So that would be this first plus equals would be of the difference of just 1, right? So it would be plus or equals to 1. And that would essentially be cutting off these guys. Then I would push my start to the next possible start and cut off these 3 values. So res plus equals 3. Then I would cut off these guys. So that would be res. Oh, well, I would extend my width to here. This was what? 3. This would be 1, 2, 3, 4, 5, 6, 7. 7. Wait, why is it 7? I messed something up. Reduce this 1. Reduce this 3. Reduce this by 4. Sorry, I missed this portion when I reduce it first by 3, and then I reduce it again by 4, and then 1, 2, 3, 4, 5, 6, 7, and then by 7. So in this case, it would be 3 plus res plus 7, and here, yes, 15, right? So 15. So that's one way of doing it. And that could be a solution. What if we try to implement it maybe a bit faster, going from still left to right, but looking at, let's see. There's this notion of a step that I can implement. For example, that if I'm looking at, if I'm still iterating from left to right, and I'm looking at the current and the previous numbers that are different in value, I could indicate that my change to have all the following guys be changed is being increased by a magnitude of 1, because it essentially means that in order to get to this value has to be changed once, this value has to be changed once, and this value has to be changed once. If I'm looking at respect from this one to how many times does this have to change, well, this has to change twice. So what if I do something like this? 1, 1, 1, 2. This value has to be changed 3 times because there's 3 fluctuations. This value also has to be changed 3 times. This value has to be changed 4 times. Does this also equal 15? Yes, it does. 15. And this one is a bit easier to go by because we don't have to keep track of the start and the end. We can just keep track of the step that we're changing. So I'm going to try to go ahead and implement that actually. let's have the nums sorted. Let's have res equaling to 1. Let's have the step equaling to 0. Let's have a while I in range 1 len nums. And here I'll say that if nums I is greater than nums I minus 1, then step plus equals 1, and then res plus equals step. Let's see if this works. This is a very clean solution. Let's see if I was correct in picking up that. Did you mean I? Oops, 4. For I in range. Silly. There we go. Okay, that worked. Yeah, so very nuanced thing to notice. You could characterize the number of steps one of these bars has to go through in order to get to its final destination through this variable called step. And the way to know what that step is equal to for each bar is just memorizing how many times that has to be changed to get to this ultimate value. And for these three, since the previous value was the final value, then the change is just 1. If at any point the next value is greater than what these guys are, right? Then it simply increases by 1 because we first need to downgrade it to this value and then we need to downgrade it here. So this notion of a step that increments or increases as you go on potentially this way lets me keep track of how many times the step is going to be, what the step is going to be for each one of these bars. And then it's just the sum of all of those steps. And you can see that we've completed this successfully. Let's see if we're doing well. We're not doing so well, but this is an extremely clean solution, and I don't know if there's any better. No, I'm looking at these right now, and it is, I like my solution way more. Additionally, these do seem somewhat similar. Yeah, step plus, yeah, this is 1-to-1. Yeah, absolutely. I like this approach way more. And yeah, please use this. Hopefully this was quick and easy and intuitive. And that's what I'm really going for in these situations, to visualize these things and then be able to apply them in later problems. With that, thanks for watching today's video. Please like and subscribe, it helps a lot, and I'll see you tomorrow. Bye.